I'm going to try and show you my learning tool, how I remember this. But you people are much cleverer at these things than what we are. I'm sure all of you have heard of Dolce & Gabbana before. Okay, right. And now I should have Googled the Dolce & Gabbana picture and showed you. The Dolce & Gabbana picture is where they have the D and the G. Okay. And then they always put them together in some way. Okay. Right. And they will, for example, put the D like that, and then they will put the G upside down or something like that. Okay? Now, what I always remember is that, yeah, over there is a split. Okay? Dolce & Gabbana sounds a lot like DC. And then I remember that there is a split. Okay. I don't know if you're going to remember it that way. I just know that my learners taught me that last year, and they all got it right. So it had to have worked at some stage for them. Right. Okay. So this in particular is a DC motor, and it's a DC motor because it has a split ring. Okay. Now, let's quickly have a look. They say to me, indicate the polarity of the battery. In other words, show me which is positive and which is negative. Right. Show how the direction of rotation supports your decision. Now, the very first thing I would have done, people, is they show you the direction. Can you see over here? They show you the direction of the electrons. And if you can remember correctly, the electrons move in the opposite direction. Hey, okay. Right. So, according to me, yeah, the other thing that I can also pick up, the other thing that I can also pick up is that the rotation is that way. Okay. Can you see the rotation is clockwise? They've showed me here. There's an arrow. Okay. There's an arrow. Right. So, therefore, we know that it is clockwise. Right. And remember what happens. My current goes from positive to negative. Okay. And if we have a look and we see north, south, there's north, south. Okay. You've got north, south. Rotation is that way. So I would say that this would be the positive. Whoops. This would be the positive, and that would be the negative. Okay. Right. Remember over here, they've given you an indication here, flow of energy is in their direction. Because remember, electron flow is opposite to the current flow, eh? Okay. So that's one way you could have worked it out. The other way that you could have worked it out is with a rotation. Okay. Right. Remember, immediately I identified here electrical to mechanical. Why? Because I had a battery. I had an input. Okay. And I also know that this is a DC power supply. Right. Now let's carry on. Right. Can any of you, here's another one. I'm not going to go into too much detail here because it's exactly the same. Can you see that the rotation here is clockwise? Right, the rotation here is clockwise. Let's carry on. Right. Now, electromagnetic induction, and this is where the difference comes in. Right. Electromagnetic conduction is when in an electrical conductor we have an accelerated flow, and there is a magnetic field, and we then get what we call an induced current. Okay, an induced current. And our induced current, that's mainly the one we're going to use on a generator. Okay, and then we are not going to use Fleming's right-hand rule. This is quite important, people, and I personally don't like this work because I keep forgetting, must I use my left hand or must I use my right hand? Okay. When we have an induced current, I'm going to use my right hand rule. And my right hand rule is going to be similar, except now my middle finger is going to point in the direction of the induced current. Okay. Look here. Here it says motion. We have motion, field, and induced EMF. Look what we had the previous one. I just want to find one. There we go. Can you see in the previous one, what did we have? We had thrust, field, and current. And this was now the left-hand rule. Now we go to the right-hand rule, and in the right-hand rule we have motion, field, and induced current. Right, so that is the direction. There we can see we're going to use Fleming's right-hand rule. Now let's quickly see if we can get the right-hand rule right. Okay, once again, remember I'm now actually going to be using my right hand and not my left hand, okay? So what's going to happen is the current, we're not going to have a look at the current first now. The first thing we're going to have a look at is the magnetic field. And can you see that the magnetic field, remember FBI, right, so the magnetic field is going to be north-south. The thrust is down, okay, because they tell you that, okay, and therefore the current will be in the opposite direction. All right, okay. Now, let's quickly have a look at a generator. This is a generator, and this generator looks a lot, okay, I don't want to say this generator, but this is an AC generator, okay? Now, why do I know that this is an AC generator? Right, there are two things that are important. Number one, can you see there was no battery, okay? But this light bulb burns, okay? So that means it's a generator. The second thing that I know it's AC is because I now have what we call slip rings, okay? These that we've got now are slip rings. And therefore, we can know that this is an AC generator. It is also sometimes known as an alternator. Right. And in this case, they have showed us the direction of the induced current. There's my arrow. There's my arrow, right? The direction of the movement, and then my north and my south. So remember, in this one, I'm going to be using my right-hand rule. And they would have asked me for the direction of the current. So first of all, I know I've got north and south. And secondly, I know I've got the direction of my thrust. Okay? So what would have happened in this case? My thrust is up, right? Oops, let me just get it right. You see that this is a way that we get ourselves stuck all the time. Right, can you see? Right, my fingers aren't working out. Let's just check it again. FBI, north and south, that's right. Thrust is right, current's right. You see? Okay. In the exam room, if I see you all going like this, I know you're busy with this rule. Okay, let's just get it right again. Right. My B is going to be north to south, right? My thrust is up, and my current is going to be moving away from me. Okay. The main thing that you must remember, people, is to use the right finger. A good idea maybe what you can do initially to get to know this is to actually write, I'm going to show you quickly what you can do, is to actually write on your hands. Just say, right, this is north, right, that is north, and that is south. Okay. And then this is your force, and that's your current. Okay. And normally if you write that on your hands, then it does get a little bit easier. Right, so let's quickly see if I use that to get the right idea. So here's north and south. So the first thing I had to do is I had to make sure that my fingers were in the right for north and south. Okay. So my fingers either could have been like this or like this. No, it couldn't have been like this because then north would have been on the opposite side. Right. So that had to be north and south. You with me? Then the direction of the thrust was up. You see that? The direction of the thrust was up from the picture because they show me. Therefore, my current will be moving away from me. Right. This is my alternating current generator. Remember, AC, and AC has got slip rings. Slip rings. They slip. Okay? The generator also has slip rings. So if you learn that once, you know that. Okay. Right, this is another word for it, what they refer to as a dynamo. It's the same thing. except the only difference in a dynamo, direct current is produced. Quickly have a look there. Can you see this slide? Look at the difference. There are my slip rings. Now look here. Is my split ring. You see that? My split ring. Okay? And remember, my dynamo is a DC generator, and it makes use of a split ring. And I'm also going to use my right-hand rule here. Same thing. Okay? Right. I think we've done quite a lot. There's my direct current generator.